Krummi svaf í klettagjá, kaldri vetrar nóttu á, verður margt að meini, fyrr en dagur fagur rann, freðin nefið dregur hann, undan stórum steini, allt frosið út í gór, ekkert fæst við ströndum mór, svengder mekki mína,
You actually was an eruption in Monson County, so it was fire, and so he kind of put that eruption, the ash boom from that eruption, together with this eruption image which he created. Those we here are interesting because those are one of the first cross-sections made in the world. They were made by this priest, Jesuit priest, that was worked in the Vulcano, well known there, and he
or in California, in a climate that was much warmer than today. We had like redwood and giant fir, and then the mean temperature was about 15 degrees, but today it's 4 degrees centigrade. So a very different climate at that time. Okay.
So these were laid down how long ago?
It's 12 million years ago. Yeah. So 12 million years ago, the climate was very much. So this is from a book that was published in 1551, the Cosmographia by Sebastian Munster, and he has a chapter on Iceland and showing Hekla volcano, a very old woodcut. That's the oldest picture we have on the Iceland volcano. This is Hekla again in 1845 when Hekla erupted. And this Danish artist was here then, and he did this aqua tint of Hekla, and you see everything is black or grey with ash, as it is, as it was last year after the eruption. And then I believe Sigurður was telling you about the Stykkishólmur, and the same artist did that. And the Stykkishólmur is, of course, at the head of the peninsula. This basalt that came out, this basalt lava, and erupted on Stykkishólmur. And that's magma that's very hot, about 1200 degrees centigrade, and comes up very quickly from the mantle, and it erupts, and it's very low viscosity. It's like ketchup, very fluid. But then, 2 weeks later, there was another eruption that started in the summit of the volcano, and it produced this. And that is a lava called, or a magma called andesite, named after the Andes Mountains in South America. So the andesite is different from the basalt. What happened there was that some other basalt came up and stopped inside the volcano, about 4 to 5 kilometers depth, and sits there for a while, and the basalt then changes centigrade. Basalt is quite rich in iron, about 15% iron. And then if it's raining while the lava is flowing, the iron becomes rusted and it turns red. Yeah. So it's a kind of rusting of the lava or of the basalt.
Because of the water.
Because of water, oxidation. Iron oxidation, ferrous to ferric. The other important magma in Iceland is rhyolite. A rhyolite magma can make all of these 5 rocks here, depending on how it is cooled. So the rhyolite, if the rhyolite magma comes out very quickly and cools very fast, it will form glass like this. We call it obsidian. And this is obsidian that is 4 million years old and has become weathered. Same thing. But if the rhyolite magma stops inside the earth and sits inside the earth, it will crystallize very slowly, and it will form granite or granophyre like this. So, and the same with the basalt magma. If the basalt magma stops inside the earth, doesn't erupt, cools very slowly, it forms what we call gabbro, which is this. This is, they're all from Stykkishólmur, these rocks, except the early ones. Yeah. So this is Vulcano. Rocks here are jasper, so they're nothing to do with magma. They're related to hydrothermal activity, hot springs. And you know that the crust in Iceland is broken, a lot of fissures. And the cold water goes down the fissures 1 or 2 kilometers, and it comes in contact with hot rock, and the water heats up. And when the water gets hot, it expands, becomes less dense, and it rises, so it's hot water. And it brings with it a lot of chemicals, and mostly silica. And the water comes up and creating jasper. And if there's a little bit of iron in the silica, it turns red, or copper or manganese, it turns green.
Yeah, you can see that on the hot springs colors.
Mm-hmm. Yeah.
What they are bringing out.
Right, the different chemicals.
I have a question.
Bubbles, yeah.
Yeah. How do they appear? Because they were also different colors. So
it's hard to say. I mean, the gas magma, it's under pressure, then the gas is in the liquid. But when the magma comes close to the surface, the pressure is low, and then the gas comes out and makes the bubbles.
How is the process of solidification of the magma? It's rapid one, is the fast one?
Well, it
or
depends.
is it slow?
It depends on the environment. So very rapid like this, it makes glass.
Yeah.
If it comes in water or a glacier or the ocean, glass. But if it's in air, it's like this.
Like slower.
But if it's inside the earth, it's like this. It forms gabbro or granite. Very slow, very slow cooling.
This is slower.
Yeah, this is the slowest.
And
this is fast.
this one. Yeah. This is fast.
Yeah.
And this is also
This is
fast.
common in Iceland, but very rare anywhere in the world. And it's formed by eruptions beneath the glaciers. So subglacial eruptions. It's called. The English name would be tuff.
Yeah.
A salt of tuff.
It's the same as in the singing cave.
Yeah. Moped. And so that is formed beneath the glaciers. And you see when the magma comes up under the glacier, it melts the ice, and you have a lot of water, and then the water it turns to steam. And when water goes from the water to steam, it expands 1,500 times in volume. It's like a bomb. And this is a steam explosion. It tears up the magma into little fragments of ash. It cools very quickly, it forms ash. And this ash accumulates on the ground, and then it hardens into this rock in a few months or a few years and makes mobek or tuff. And the Hrapsey, just outside Stykkishólmur, out in the bay, and it's the only place in Iceland where we find it. It's very rare in other parts of the world, but it's very common on the moon.
It's common on the moon?
Yeah. You look at the moon, you know that there are dark areas and light areas on the moon. It's not all the same color on the moon. The light areas on the moon are known as the lunar highlands, and they're made of this. And if you look at it, you'll see that it's got big crystals in it, all full of big crystals. And these big crystals, they're all the same type. They're a plagioclase, a mineral, and it's this size. It forms this layer, and then the layer solidifies to form this anorthosite. And then the volcano is eroded over millions of years until it's eroded down to this level, and we can study it. So, similar story on the moon. Yeah, very, very beautiful rock, very hard and strong, but very rare. So, I think we've covered all the important rocks. Okay. We have some things here in the cabinet that are for tools, to make tools. And these are 7 tools from the Stone Age from the island of Milos in the Aegean, in the south of Greece. Milos is a big volcano with lots of obsidian, and it is, and they used to export it all around the Mediterranean from Milos and to make tools. Out into space, drains down back to Earth as pearls of glass. And those are the Pearls of Glass watercolor by Vigner Johansson, and this is a panorama by Johan Isberg of the eruption. And here, if you look, you'll see magma that came straight from the mantle and didn't stop and came out and erupted here. And behind that we see Goðabunga, and Katla volcano is over there. And then this is the Eyjafjallajökull eruption, and there the basalt magma came up to about 4 kilometers and stopped, and then changed to andesite. And then the andesite erupted explosively. And here you see the ash fallout and the flooding and the effects of the eruption. Here's a ridge, and this is an old lava flow under the glacier, and that is formed from the first historical eruption, 920. Was the first eruption that we know of here. I think the Tambora eruption in Indonesia in 1815, 100 cubic kilometers. Yeah, well, there was a flood a couple of weeks ago that took out the bridge. And that flood, some people say that flood might have been caused by a subglacial eruption. And some other scientists say that it might have been produced by hot spring activity under the ice. So normally in these volcanoes there's a lot of melting going on underneath the ice because there are hot springs under 500 meters of ice. And then over time a large body of water collects, and then the ice floats on water, right? So if they get a lot of water, the ice may float up, and then the water can flood, and then the ice comes down again.
Yep.
So that is quite common. So nobody knows for sure whether it was a real eruption under the ice or whether it was just a flood because of melting hydrothermal activity. I don't know either. And it was just the same in 1955. It was exactly the same. A flood, and the bridge went, the roads were damaged, and then everybody was guessing, is it some glacial eruption or is it just melting? Same story. We need more information. And so now there's nothing in the air indicating anything unusual, except that people are very nervous. And especially the media.
Yeah.
The media, and maybe the food.
Spyrja það, já. Já, og svo ef ég spyr ykkur jarðfræðinga, að það var kannski 2-3 svör.
Já. Sem verða þeirra út filminu, sko.
Já, hún er ekki að fara með þetta neitt, sko.
Nei, ég segi svona.
The man you meet in the museum, and he is from this place. He is from Stykkishólmur. He was born here, yeah. And he loves this area. It's very interesting. We go maybe once or twice a week.
karlaróm. Útilegu menn í Ódáðarhraun eru kannski að smala fé á laun. Útilegu menn í Ódáðarhraun eru kannski að smala fé á laun. Rekum yfir sandinn, rökkrið að síg á herðu breið.